So first, welcome to this session. Thanks for coming. It's quite early. Today we're going to discuss Java 8. Something, if you have been following the news, that I will also quickly address is E4J. And basically, what applies for Java 8 today will apply for E4J. And E4J, for those who don't know, that's basically that Eclipse project that will host the development of the next iteration of Java E. So my name is David Delabassee. I come from Belgium, so I'm mostly local. You can find me on Twitter at Delabassee. I work at Oracle in the Java and Container Native Platform organization, so I do report directly to HQ in the US. So in our org, we are responsible for technologies such as Java E, Java EC, but also open source projects such as GlassFish, Jersey, OpenJDK, and other stuff like, for example, a WebLogic server, which is our Java E commercial product. We are also doing other stuff, cool stuff like FN project, so a polyglot open source serverless platform, which has been launched a few weeks ago at Java 1. So today I'm going to discuss about Java 8. Before I do so, some logistics. So this was me a few months ago at JFocus in Sweden, and someone in the audience said that it's not a real conference unless you read Oracle's safe harbor statement at least once. So please enjoy. You can try to understand what it says, but basically you shouldn't make any purchase decision based on forward-looking statement that I will do today. Java 8 is finalized and has been released, so we're on the safe side. So today I'm going to discuss Java 8. I will basically give you a quick overview of the new thing that we have done in Java 8. And in a nutshell, Java 8 is about modernization of the platform and simplification of the platform. And you will basically see that through my presentation today. So, the first API that I want to discuss is JAX-RS. So, in Java E7, we have updated JAX-RS to JAX-RS 2. And the big thing in JAX-RS 2 was the addition of a client-side API. So if you look at JAX-RS, that was basically a server-side framework that you can use to easily expose REST endpoint. But when you had to consume those endpoints, you basically had to write your own client code, either using third-party library or using a very low-level API, such as HTTP URL connection. That has been solved in JAX-RS 2. We have an easy-to-use client-side framework that you can use to consume your REST endpoint. It works like this. So we have this notion of a client-side JAX-RS container. So you need to have an instance of that client container. So client builder, new client will return you this client. Then from that client container, you need to construct the web target. So that's basically where on the network the remote endpoint is. From the web target, you will then construct the request. So that's what I'm doing here. In this case, I accept application JSON type. I can set some headers and so on. And then once you have the request, you will issue the request to get some response at some point in time. That's what I'm doing here. So this is an HTTP GET request. I expect to have a list of forecasts as a return. So now we have this Fluent-based API that we can use to consume a REST endpoint. The thing is that in this code, this is a blocking call. So as soon as you do the GET, basically your method will not return until the remote endpoint has sent the result back. And this is so because we are using the default invoker, which by nature in JAX-RS 2 is blocking. So it's a synchronous invoker. So you see in the first example, I'm not specifying any invoker, so that's a blocking call. Now, the good thing is that in JAX-RS 2, we also have an asynchronous invoker. So if you look at the bottom of the slide, we have this async method. So that is basically the same request, but this time we are telling to the JAX-RS client container that we want to do this request invocation in an async fashion. And if you look at the return type, now we don't have a string anymore, but we have a future of string. So that basically means that we have a future object that we'll be able to use at some point in time to get the result that will be sent by our remote endpoint. Get the result or get the error that might happen. So we have a future object, so that means that at some point in time we will do a get on that future object. And you know that doing that is basically a blocking call. So yes, we have an asynchronous behavior in JAX-RS 2, but we haven't solved the issue because the first call is not blocking, but the second call, the one that will get you the result, is a blocking call. And also, you have to, so this one is blocking. So something that you have to make sure is that given the fact that you are going through the network, it's maybe a good idea to set some timeout on the JAX-RS level to make sure that if the network takes too long to send the result back, your code will not be stuck forever. And you might also set a timeout on the GET itself. But again, this is not a solution because at the end of the day, this is a blocking call. The good news is that in JAX-RS 2, we have also added an invocation callback facility to basically overcome that issue with the async behavior that is blocking. So we have an invocation callback with two callback, completed and failed. So completed will obviously be invoked when we have the result from the remote endpoint, and failed will be invoked if something goes wrong. So it works like this. So this is a pure JAX-RS client invocation. So it's an async request invocation. But this time, when I'm doing the request, I pass it an invocation callback implementation with my two callback, right? So the completed callback and the failed callback. So that basically allows us to overcome that blocking issue. Now, if we put that in perspective with a very simple microservices-like scenario where we have a travel agency services that will provide to a user some potential destination with a weather forecast and quoting, so pricing information for all the destinations that will be suggested. So it goes like this. So the user connects to the travel agency services. The travel agency services will have to implement some kind of orchestration to basically consume the 4 backend services. So the first request will go through the customer services to get the travel history for that given customer. Once we have that, the travel agency services will invoke the destination services to get some potential destination to suggest based on the history of the customer. And once we have the destination that we're about to suggest, we want to invoke the weather services and the quoting services to add some pricing and some weather forecast to the destination that we're about to suggest. So that means that the travel agency services will have to implement this very simple orchestration between the multiple backend services using the JAX-RS client-side API. Now, if we put a weight on all the requests that we have to do, we know that we don't want to do that in a synchronous fashion. Why? Because let's say that we have 10 destinations that we want to send to the user. So that means that for each destination, we will lose a lot of time. Because we'll have to do 10 requests to get the quoting for that destination, and then we'll have to do another 10 requests to get the forecast for those 10 destinations. So we want to do that in an async fashion because we see that there are some dependency between the request invocation. For example, we first need to have the customer details before invoking the destination services. But for example, once we have the destination, so once we have the 10 destinations that we will suggest, we can invoke in parallel the destination, the quoting services for that given destination and the weather services for that same destination. And we'll have to do that 10 times. And obviously, at the end of the day, the overall time that it will take to get all the results should be shorter. So if we try to implement that using the JAX-RS 2 API, well, first, I will simplify that services. So originally, we had 4 backend services, but for the sake of time, I will just pretend we have 2 services, the weather services and the destination services. So if we look at the JAX-RS 2 existing async API, it would work like this. So we first do a request. It's an async request, right? So that means that, that request is basically to get the destination that we want to suggest to the users. So it's an async request, so that means that we need to pass it an invocation callback. That invocation callback has 2 methods, a completed method, so that's basically when we have all the destination to suggest. Once we have all the destination to suggest, we will do another request, so we will basically iterate over all the destination and do another request, which will be an async request each time. So that means that we have to pass it a completed callback. So basically, so that second request is to get the weather forecast. So basically, when we have the destination and the weather forecast, we put that in a synchronized map. And obviously, we also have to deal with the error. So we have to implement the 2 failed callback for the two invocation callback that we have. So I guess that you see where I'm going to. So this is basically going to be a mess. It's what we tend to call the callback hell. That's also why I had to simplify the code from 4 services to 2 services, just to try to make it fit on 2 slides. That code is very difficult to write, debug, and maintain. The good news is that in JAX-RS 2.1, so Java 8, we have a third invoker. We have this RX reactive invoker. So it's an async invoker, but it's a reactive one. And if you look at the return type of that one, it's not a future object, but it's a type, it's a completion stage of the response type that is being sent by the response, sorry. So the completion stage API, for those who don't know, that's an API that has been added in Java SE 8, where we have this notion of stage. A stage being an asynchronous task that may or may not produce result. And the completion of a task can trigger the execution of another task. So basically, the completion stage API gives us this ability to define the orchestration that I was mentioning earlier. So we have this notion of asynchronous task pipeline execution that we can easily do. So an example would be this one. So we have a first request. So it's an async request, but we are using the reactive invoker. So this first request, given we are using the reactive invoker, returns as a completion stage. So this first request is basically going to an external services just to get my public IP address. We then have a second request, which takes a JSON object. And this one is wrapped in a function. And that second request basically takes a JSON object and, no, sorry, it takes just an IP. It takes an IP, and that one will basically invoke an external services to get the geolocalization based on the IP. So now I have those 2 requests that I want to chain in an async fashion. So all it takes is to use the completion stage API of SE 8. So I first do the first request. Then I'm using the then compose method coming from the completion stage API. I pass it my second function. So basically I'm saying, okay, do the first request. Once you have the result, once that request is done, you take the result of that and you invoke the function which will get the result of the first request. And that function happens to be another JAX-RS async invocation. So the second request invocation is done, so then I just need to basically do something with the result of the second request invocation, and in this case, it's just a simple consumer. So I have this travel agency services running on my laptop, so I have the travel agency, I have everything running, in fact, on my laptop. So the main services that perform the orchestration, and then the 4 backend services. So if we look at let's see. So for example, I have here, so I will zoom a little bit. So I have the backend services. So if I invoke this one, I will get some result. And everything is randomly generated. So if I invoke it multiple times, I will get a different result. I have quotation services, right? So from Paris to Boston, it costs that much. Now, what I have running here is also the orchestration using different approach. So the first one is this one, the synchronous one. So let's invoke it. And well, you see that it takes a bit of time, like, more than 4 seconds. And if you see here what we have, we basically have the history of the customer. We have a few destinations that we want to suggest to the user, like this one, with each time the forecast and the pricing information. And we have that multiple times. So this is a pure synchronous approach. Now, what I will do, I will invoke the same one, but using the async approach, using the invocation callback facilities of JAX-RS 2, so not the JAX-RS 2.1. And well, you see that it was way faster. Just around 900 milliseconds, so below 1 second. And again, we have all the result, right? We have the destination to suggest, and each time we have some pricing information. So just something related to this. A few weeks ago, well, it has nothing to do with Java 8, but a few weeks ago I was in Tel Aviv where I gave basically the same demo. And you know, sometimes when you leave Israel, you have to go through a screening interview, basically to explain what you have done. So I was the lucky winner. I had to go through that interview before leaving Israel. And I basically had to explain what I've done the day before. So, well, I did a conference on JAX-RS 2. Oh, and can you tell us more about JAX-RS 2? Well, JAX-RS 2 and JAX-RS 2.1, and here are the new stuff. And obviously, the guy on the other side, which is an army officer, had no clue what I was talking about, but I had to be convincing. So I had to show my slides. And then in my slide, at some point in time, I had a slide demo. So I had to do, at the airport, my demo in front of an army officer. And I can tell you that the blocking behavior that takes nearly 5 seconds is really long when you have to wait in front of an army officer. Believe me. Anyway, back to this one. So what I have also here is basically the same orchestration scenario, but using the completion stage API, so the RX invoker of JAX-RS 2.1. And if you see, basically, we have nearly almost, well, we are on par with the pure async, with the JAX-RS 2 invocation callback facilities. And again, we have all the results and so on. So basically, in terms of performance, we're on the same level, not faster, not slower. So back to the slide. So the question is really when you should use this new RX invoker. Well, as soon as you have any services invocation where you have dependency between the services, you'd better use the RX invoker because clearly the code is easier to write, maintain. You can do it using the pure async API of JAX-RS 2, but that's clearly difficult. And also the RX invoker is using this new completion stage API of Java-SE 8, which is nice. Having said that, we also know that the completion stage API is not the only reactive API in the market. So the JAX-RS specification has been designed in a way to allow other API to be supported. It's up to the JAX-RS implementer to decide if they're going to support those. So for Jersey, we support the completion stage API. That's mandatory. But we also support the Guava listenable feature and RxJava and RxJava 2. So this is something which is quite nice. I will skip this one. This is a small feature. So another big addition of JAX-RS 2 is SSE support. So SSE is basically a one-way mechanism that can be used to push from the server payload to the client. It's supported by most of the most of the modern browser. And this is something which is widely used. So we're adding support for SSE in JAX-RS on the server side, but also on the client side. And obviously, if you're using JAX-RS SSE support on the server, you can combine that with, let's say, a browser that supports SSE and its JavaScript API. So in JAX-RS 2.1, we're adding this super interface, SSE event, which basically just represents an SSE event. It's extended on the two sides of the connection. So we have an outbound SSE event, which is the server-side view of an SSE event. And then we have inbound SSE event, which is the client-side view. This is one way only, so it's server to client. So that means that you will create the event on the server, and on the client side, you will not create any event. You will just consume the events that are coming through your SSE channel. So we then have this object, basically, to represent the SSE connection. So SSE event thing is a connection. It's an outbound connection, so this is the server-side view of the connection. And how it works? Well, the idea is really to leverage as much as we can from the existing JAX-RS API. So this is the standard JAX-RS resource method, so we are on the server side. We are injecting two objects, SSE event thing, so the connection object, and SSE, an SSE object, which is just some kind of convenient object that we can use to make our life a little bit easier. Then we are just using the standard JAX-RS annotation. So this one will answer to a get. That's his path in my on the network, and it will produce that specific SSE media type. Right? There's nothing really special here. Then, at some point in time, hopefully, your server endpoint will have to push some payload to the connected client. To do that, you just take the connection object, so the event thing object, which has been injected, and you invoke the send method on it, and you are done. What you need to do, you just need to pass it some SSE event. And that's why I'm using here this SSE object that has been injected. It's basically an easy way to create easily SSE event. You will do that multiple times, and obviously at some point in time when you are done, you will have to actually close the connection on the server side, right? So this is very easy to use. We also have this SSE broadcaster. So that's an SSE broadcaster is just a collection of connected SSE endpoints. So instead of sending a one-to-one, so you send directly to the connection object. So you are sending directly to a connected SSE remote endpoint. If you are sending to a broadcaster, you just broadcast to all the connected SSE endpoint of that given broadcaster. Then on the client side, we have SSE event source. So that's basically the client side view. So we have the client side container. We set the web target of our remote SSE endpoint. Then what we need to do, we have to create the connection object. So SSE event source, we set the target. We have the ability to configure it, and we will invoke the build method to actually construct the object. So we are not establishing the connection at this point. What we also need to make sure, we need to make sure that we do register a few callbacks. One that will have to be registered is the one that will consume inbound SSE event type. So basically, that guy will be called whenever there are some incoming SSE payload coming in. In this case, I'm just consuming it, so I'm just printing what is being sent. You can also, for example, register a throwable type. If something goes wrong, that one will be invoked. And then what you need to make sure is to, on the connection object itself, invoke the open method. So that's basically where you tell to the client-side container to establish the SSE connection, to register all the callbacks, and so on. And from that point on, at any time the remote SSE endpoint will push through SSE payload, automatically your consumer of inbound SSE event type will be invoked. And obviously, once you are done, you need to make sure to close the connection. So here I'm using the try with resources, so I don't really close. Well, the connection is automatically closed for me. So that was a very short overview of some of the new stuff that we're doing in JAX-RS 2.1. SSE and this new RX invoker are clearly the two major features of JAX-RS 2.1, but there are a bunch of other smaller features. Now let's talk about what we're doing on the JSON front. We're doing two things. We have updated JSON P11. So the JSON P API that has been added in Java 7 has been updated. And we have introduced a new binding API. So if we look at the first one, JSON P, basically JSON P11 is about adopting a standard coming from the JSON space. The first one, JSON Pointer, is a standard that is used to basically reference a location within a JSON document. So it's a very easy to use syntax. So you see an example there, /event /location, for example. So /event means we want to use the object whose key is event, and in that object we want to use the object whose key is location. So if we look at a concrete example, so I have a JSON P object whose JSON representation is on the right side of the slide. So it's an array of two conference. So if I want to use the JSON Pointer API, I first need to create my pointer. So in this case, /1 means we want in the array, we want the object at index 1, so we want the second one. And in that object, we want the key value whose key is venue. So now that we have the pointer, we need to do something with it. So we have a few methods that we can use. GetValue is one of them. So on my pointer, I invoke the getValue and I pass it which JSON document I want to work on. And basically what I will get in return here would be Hilton. I also have the replace operation. Given it's a replace operation, we need to specify what the new value will be. And what you have at on the right side at the bottom would be the new document when we perform that operation. Something which is important to mention, the JSON P API is an immutable API. So that's why when I'm doing a replace operation, I get a new object. We're not changing the original object. And then we have a few additional operations that we can use, like add, remove, and contains value to test if we have a specific key value. So another standard that is part of JSON P11 is JSON Patch. Again, the name is very obvious. A patch is just used to modify a JSON document. So the patch in itself is a JSON document. So that you have an example on the left side. So we have a JSON patch, in this case, with 2 operations. So a patch is a JSON document with 1 or more operation. And the patch is atomic, meaning that if one of the operations fails, the complete patch is aborted. The JSON patch is using the JSON Pointer syntax. So that's why you are, for example, the first operation is a replace operation, the path is /0/venue. So if we're going to apply this one, so /0 means the first object, /venue means the key value whose key is venue. So it's a replace operation. It works. So we can move on to the next operation. It's an add operation. And this time we are adding a new key. So that would be the end result. Now, if we look at the Java side of the API, we have 2 JSON documents. The first one is the document that we want to apply the patch to, and the second one is the JSON patch itself. So we first create a patch using a JSON document, and then we just need to apply the patch to a specific target. So that would be the document that we want to modify. Again, this is an immutable API, so that means that we would get a new document. Now, something that we have in JSON P11 is also this builder pattern-based API, where we can directly create the patch. So we don't have to go through JSON document creation to create a patch. We can directly construct the patch basically on the fly. So this patch has, for example, 2 operations. So copy, replace. Yeah, something is wrong in my slide. Because when I create a patch using the patch builder, I need to make sure I invoke the build method at the end to actually create the patch. But anyway, you get the idea. So we create the patch using this operation, then we invoke the build method to actually build the patch, and then we apply the patch to the document that we want to modify. A third standard that is part of JSON P11 is merge patch. So in JSON patch, you basically have a JSON document with operation that will be applied to another JSON document. In merge patch, you want to modify a document, but this time we'll just use key value to basically describe the difference or the operation that you want to apply to a specific target. On the Java side of the API, it works exactly the same way. So we have these 2 ways of basically modifying a JSON document, but the nice thing about JSON P11 is that we also have the reverse operation. So we have the diff operation basically to compare 2 documents. And what we will get in return would be a JSON patch or a merge patch that will describe the difference between 2 documents. Something which is also part of JSON P11 is this. So this is pure JSON P1.0 code running on top of SE8, so I'm using the Stream API, and you see that at the end, I basically have to write my own JSON collectors, because there is no JSON collectors in JSON P1.0. In JSON P11, this is solved, so we have introduced specific JSON collectors, so you don't have to create your own JSON collectors. And then there are a bunch of other smaller stuff that are done on the JSON P side. Now let's move on to this new API that is added to Java to Java EE8. That's JSON B11. So it's basically an API that you can use to marshal and non-marshal Java object to and from a JSON document. So it's convention over configuration. So the specification defines basically how the marshalling and non-marshalling will be done by default, and you as a developer will have the ability to override that behavior. So it supports basic type. It also supports a bunch of specific JDK types like URL, URI, dates. For example, on the date side, on the JSON side, we have one way to represent a date. That's a string. On the Java side, we have a bunch of different types. So the specification clearly defines the conversion between the 2. It supports classes with inheritance, collection, array, enumeration, and so on and so on. And I have an example here. So I have this simple POJO, which is a list of events. So if I want to convert that to a JSON document, I need to have a JSON B object. So JSON builder create will get me that JSON object. I'm not specifying anything, so that means that I will get the default behavior. And then I just have to invoke the toJSON method. I pass it my Java object, and what I get in return is a string with that specific JSON payload, right? So it's very easy to use. It obviously works the other way around. So this time I have, So I have this JSON document that is on the right side, and I want to convert it to a Java object. So again, I'm using the JSON B object. This time I'm using the from JSON method. I pass it my string that contains my JSON payload. I pass it the type that I expect to get, and what I will get in return would be a Java object with all the fields coming from the JSON payload. Obviously, I can pass it a reader or an input stream. That's something that is supported by the API. So the way you will customize the API is, for example, using annotation. So in my previous example, I haven't specified anything, so that means that everything was inferred from the Java type. In this case, if you look at the class event, for example, if I don't specify anything, the event name would be event name, right? But this time, given that I'm using this JSON B property annotation, it's basically a way to tell to the API that I don't want that field to be called on the JSON side event name, but I want it to be called a conference. You can apply those annotations at different levels. And there are a bunch of ways to configure the behavior of the JSON B API. You can set the naming strategy, in which order the property should be set, what should be done with if you have binary. Maybe there's some property that you want to ignore in the conversion. What should we do with the null? By default, they will be ignored, but in some times you might want to carry them, and so on. So we saw that by default, if you don't specify anything, you will get the default behavior. You can use the annotation to configure the API, but you can also use this JSON B config object to basically specify how the marshalling and unmarshalling should be done. So you create that configuration object, and you pass it to the JSON builder to create a specific JSON B object with that behavior. And more importantly, something that I didn't mention is the fact that the JSON B API, at the end of the day, is just a standard API that is sitting on an existing JSON B framework. I mean, there are already a lot of JSON B frameworks, so we don't want to reinvent the wheel. So you, as a developer, will have the ability to use the standard API, and then you will have the possibility to switch to a different JSON B frameworks. So I think that today there are 3 frameworks that are supporting the JSON B API. If you don't specify anything, you will get the reference implementation, which is Eclipse JSON. But you could switch, for example, to JSON, for example, if you want to do so. So let's move on to the web front. On the web front, the big deal is Servlet 4. Servlet 4 is about adding support for HTTP2, so server-side HTTP2 support. There are a bunch of other stuff that are done in Servlet 4, but clearly Servlet 4, it's really about adding support for HTTP2. Now, I don't have the time to explain HTTP2 into details, but HTTP 1.1 was a text-based protocol. HTTP2 is a binary-based protocol. In HTTP 1.1, if you need to fetch multiple resources from the same host, your client has basically to do multiple requests. That means opening multiple TCP sockets, which is very expensive in terms of resources on the client side, but also on the server side. In HTTP2, given that it's a binary protocol, everything happens over that single connection that is open, over a TCP socket, obviously. But in HTTP2, we have this notion of streams, which is just a logical connection. So over one physical connection, you can have multiple logical connections. And at the end of the day, this should reduce the latency of your web application. So if you just have to remember 2 things about HTTP2, it's a binary-based protocol. And HTTP2 preserves all the semantics that you have been using for years. So we still have this notion of request response. We still have this notion of HTTP headers, HTTP cookies. We still have the notion of verbs, and so on and so on. So for you developers, nothing is changing. Nothing is changing unless you want to use a specific feature of HTTP2, which is server push. So server push is basically about giving the ability to an HTTP server to proactively push resources to a client. So in HTTP 1.1, the client do a request, the server will answer with one response. In HTTP2, the client do a request, and the server has the ability to answer with one response or multiple responses. And this is typically used to push stuff in the cache before the client even knows that the client will need those resources. So if you want to do that, you will have to change your code. So this is always the push API is always tied to an incoming request. So it's not like SSE where you have a completely asynchronous way of pushing stuff to the client. There should always be an incoming request, and then the server can decide to answer with one or more responses. So I have my incoming request here, and I want to have a push builder object for that given incoming request. Then I have the ability to configure the response that will be used to push the resources, like setting headers, for example. And obviously, I need to specify the path of the resources that I want to push to the client. And then I just need to invoke the push method. So this is basically a way to tell to my servlet container to try to push that resources proactively to the client. Now, there is no way to know if the resources will be effectively pushed to the client. So you shouldn't assume that because you have pushed the resources that it will be there at the end. But at the end, this is another way to try to reduce the latency of your web application. Now, if we move on the web front, we have Java server faces. And the nice thing with JSF 2.3 is that it supports HTTP2 out of the box because it runs on top of Servlet 4. But it also supports HTTP2 server push transparently. So you take an existing JSF application, you deploy it on top of Servlet 4, on top of a Java 8 application server, and automatically your application, your JSF application, will use not only HTTP2 but also server push, and you don't have to change the code for that. So this is one of the nice additions of in JSF 2.3. But I mean, there are a lot of goodies in JSF 2.3. Like for example, we have a WebSocket component, so you can directly support. You can push, in fact, a payload from your JSF application using a JSF component. So the WebSocket API is not exposed. All you are using is a standard JSF component with a standard JSF programming model. So on the web front, we have Servlet 4 and JSF 2.3. Now let's move on to two other API which are part of Java 8, and that is CDI and Bean Validation 2. Those two API are led by our friends at Red Hat. And if we look at CDI 2, so first, CDI is clearly the backbone technology of Java EE. What I mean by that is that if you look at most of the API of the Java platform, they are relying on the CDI API. It's a quite rich API, so we obviously have dependency injection, but we also have context capabilities, we have interceptors, we have an event mechanism, and so on and so on. So at the end of the day, the CDI spec was getting a little bit too wide, too rich. And that was clearly an issue for people who wanted to use some part of the CDI API, typically on top of Java-EE. So the API was so rich that, well, the CDI container was sometimes bigger than the Java-EE application that was going to use it. So CDI 2 is mainly about boosting the adoption of CDI outside of the Java EE ecosystem. So it's not something that is clearly important for us today as a Java developers, because basically CDI, the whole CDI API is part of the platform, but that's something which is quite important for the CDI ecosystem. So what they have done in CDI 2, first they have split the specification in three. So you have CDI core, so that's the core specification. Based on that, you have CDI for Java EE, and then based on that, CDI for Java EE. And that's obviously what we, Java EE, are consuming. We are consuming the whole CDI API. Something else that has been done related to that effort in CDI 2 is basically to standardize how you can bootstrap in a standard way a CDI container. Again, this is not something which is important for us Java developers because the CDI container is managed by the Java EE application server. So it's not an API that we need to use if we are just programming against the standard Java EE API. Nevertheless, in CDI 2, there are improvements that are very useful for us Java developers, like this. So, if you have been using CDI, you know that we have this nice event mechanism since CDI 1.0, in fact. So it's a producer-consumer patterns implementation, and there is no tight coupling between the event producer and the event consumer. So it works like this. So somewhere in my application, I will at some point in time fire an event. So you see this event type fire. So basically, I just want to raise an event. I have the ability to attach some payload. And then somewhere else in my application, I will consume that event. So I have a consumer. So a consumer is simply a method that is using this @observer annotation. So this is basically to tell to my CDI container that this method should be invoked whenever that given method is fired. The thing is that you can have multiple observers. This is a pure synchronous behavior. So if you have multiple observers, until now you had no way to know in which order they would be invoked. It was up to the CDI implementation to decide that. In CDI 2, we have the ability to set the ordering of when we have multiple observers. So it's a welcome addition. Now you can know exactly in which order they will be invoked. And more importantly, in CDI 2, we also have this. So if you look at the previous event example, everything was done in the same thread. This was asynchronous. So you fire the event, and in the same thread, you are consuming the event. In CDI 2, we have async event. So it works exactly the same way. So you see that this time I'm using the fire async method. So I want to fire this method in an async fashion. You see that the return type is a completion stage object. So that basically means that I have an object that I will be able to use at some point in time to, for example, check if everything went fine or if there has been some error. And then I also need to specify on the consuming side that this is indeed an async consumer. So again, it works the same way. So I have a method, but this time I'm using the @observes async annotation to tell to my CDI container that this is indeed an async observer. So this is a very nice addition to the overall Java EE programming model. And also, you see that on the JAX-RS side, we are using completion stage for the reactive invoker. On the CDI side, we are starting to use the completion stage API too. So basically, you can try to combine things in a more event-driven way using those APIs. Another API which is led by Red Hat is Bean Validation 2. If you look at Bean Validation 2, two focus, adopting Java SE 8 and introducing new constraint validation that were part of Hibernate Validator. So basically standardized validation that were already part in Hibernate Validators. So, for example, in Java SE 8, we have the ability to set annotation on parameterized type, so we can do this kind of validation now with Bean Validation 2. So, for example, the first example, so we have a list of emails, and what you want to do in this case, you want to apply the not null and the email validation on all the elements of the list. So not on the list object itself, obviously, but you want to make sure that all the emails you have in your list are not null, and also comply with your email validation. Bean Validation 2 support optional type that has been, the optional container that is part of SE 8. It also supports validation using the Java SE 8 date and time API. In Java SE 8, we have the ability to repeat annotations. So now you can also repeat constraint validation without any tricks in Bean Validation 2. So, moving on, and I will conclude by talking quickly about this new API that we are adding to Java EE 8, and that is the security API. The name is a little bit misleading. The fact that we're adding an API, a security API in EE doesn't mean that Java EE was not secure before. The goal of that API is really to simplify how you can apply security aspect in your Java EE application. So one of the things that this API is adding is this notion of identity store. An identity store is basically an abstraction where you will store colors details, like username, user details, and so on. Behind the scenes, it can be a database, an LDAP, it doesn't really matter. And the identity store will basically perform the validation. But at no point in time, in the identity store will directly interact with the color. So this is an example of an identity store which is defined in the security API. This is a database identity store. So basically, I'm using this annotation to specify how my users are stored in my database. We also have an LDAP one, And obviously, you have the ability to write your own identity store. So you just need to implement this identity store interface, and you just need to implement, in fact, the validate method. You can also use an identity store to get additional details. Then you will have to implement the getColorGroups method too. Something else which is part of the security API is a new authentication mechanism facilities for web application. It's something that we already have in the platform. It's the JASPIC API, but if you have been using the JASPIC API, you will agree that it's a very difficult to use API. So this is basically a simplification of that and just for web application. And we expect the authentication mechanism to leverage the identity store that I've just mentioned before. So the specification is defining 3 authentication mechanisms, basic auth, form auth, and custom form auth. So this is very basic. But you, as a developer, have the ability to write your own authentication mechanism using this HTTP authentication mechanism interface. And again, the only method that you need to implement is the validate request method. So if we put that into perspective, so we have a servlet that we want to secure. So we want, in this case, we only want to allow the user in role foo to access that servlet. So in this case, I'm passing it a custom HTTP authentication mechanism. So it's my own implementation. So I need to make sure that I implement the validate request. And I'm injecting a custom identity store. And this is all it takes to implement a custom HTTP authentication mechanism using a custom identity store. So you see that it's easier than it was before. So we have a few minutes to wrap up. So Java E8 is really about modernization and simplification of the platform. So I've shown you a few examples on how we tackle that. One of the things that I didn't mention is that Java E8 is based on SE8. So basically, whenever we had to update an API, we tried to make sure that we could leverage what was provided by SE8. What's not on my slide is also all the API that went through a maintenance release, like GPA, for example. So in GPA, now we have the ability to support the Stream API. We have the ability to support the Data in Time API of Java SE8. So Java E8, today, GlassFish 5, everything has been finalized. You can use GlassFish 5 today to play and use all those APIs. And obviously, shortly, we will have other implementation coming on the market. Everything is on GitHub, so you are really encouraged to check what is there and what you can do with those new API. Now, I have like 1 minute to quickly talk about E4J. So this is a slide that I was using last year because there were a lot of discussions regarding the future of Java EE and a lot of FUD and, well, a lot of questions anyway. So now that we have finalized Java E8, first, we as Oracle will support Java E8 in our commercial supported product, WebLogic. We expect other application servers to also support Java EE8, but we want to basically tackle all the questions that were raised in the past, like from EE7 to EE8, it takes 4 years, which is too long for the market today. So basically what we have said as Oracle, the steward of Java EE, well, we want to open source the development of Java EE. So we are moving the development of Java EE to the Eclipse Foundation to make sure that basically we can evolve the platform in a more rapid pace. And we also want to make sure that you as developer have the ability to more easily contribute to the development of the platform. This is done under the EE4J project and under the Eclipse Foundation. This is something, I mean, we are just at the early days of that effort. We have announced that mid-August. Since then, IBM, Red Hat has joined us. Pyra, Tommy Tribe are also helping us. So if you want to learn more about EE4J, I would encourage you to come to a panel that we have tonight where we, Oracle, IBM, Red Hat, Pyra, Tommy Tribe, the London Java community will basically discuss EE4J, and you will have the ability to ask a question and make comments about EE4J, because we really think that EE4J is key for moving the platform forward. So with that, I would like to thank you. We are just in time. Well, I have 30 seconds for one question. So is there any questions? Yes, sir.
With the JSON pointers, what happens if the pointer doesn't exist in your object?
So the question is, what happens if the pointer? So basically, using the JSON pointer, if you point to a syntax that doesn't exist in the JSON document, you will get an exception. Any other questions? So I will conclude. So we have the panel tonight. There is a specific session on Bean Validation 2, and then we also have a session where we will discuss in a little bit more details the pattern that we can have using the JAX-RS completion stage support with the CDI completion stage support. So thank you.